Hi and welcome back. Previously we've seen how to do argument unpacking. We looked at this in section 10. For example, we could have something like this add all function that takes in 4 arguments, a1 to a4, and then returns a1, a2, a3 plus a4. We can call this function, of course, with multiple values. And of course, I have talked and written code, so I've written returns there. Not what we want. We can call this with 4 values and run that, and that gives us 16. Or, if we have the values somewhere else, like this tuple here, we could pass each of the values of the tuple as a separate argument. We've looked at this earlier on. The way we would do that would be by doing asterisk vals, like so. And as you can see, we get 16 again. All this has done is unpacked the iterable into multiple arguments and passed each one as a separate positional argument there. Similarly, we could have a dictionary of values where we have a1 is 1, a2 is 3, a3 is 5, and a4 is 7. And if we wanted to pass in each value to the corresponding parameter, noticing that a1 has the same name as the parameter here, we could do double asterisk vals. And then again we get 16, but now each argument has been passed as a named argument, essentially doing this. And then a2 equal vals a2 and so forth. Okay? So we've looked at how we can pass in arbitrary numbers of arguments or named arguments, but we've not looked at how we can make our function accept an arbitrary number of arguments. And actually it's really simple because it's exactly the same syntax. If you do star args, now what you get is an iterable of arguments. Let's print them out. As you can see, now we can pass in any number of arguments. This is not a tuple or anything. These are just arguments that we're passing into the function. And the function will gladly accept them and then prints them out as a tuple. But when we passed it in, this was not a tuple. These are all separate arguments. So we can use star args to accept any number of arguments. And then we can, for example, add them all together, return sum of args. And we can print this out. And as you can see, that's all fine. Okay, these args is a tuple of all the arguments we passed in that have no names. If we want to make sure the function can accept named arguments, again, you probably guessed it, all you have to do is do double asterisk and then the variable name. It's common convention to have asterisk args and double asterisk quargs in Python, but this could be anything you want. And then we can do something like for kv in quargs.items. This tells you that quargs is a dictionary when it comes in. We can do something like print for k we have v. And then we could do pretty print something like username is Jose123, access level is admin, let's say. And then we can run that. And what we get back is for username we have Jose123, for access level we have admin. These were condensed into a dictionary and passed in as keyword arguments. Of course, another option would be what we've looked at previously, which is to pass in the dictionary itself. In this case, something like username is Jose123, access level is admin. If we run this, though, it doesn't know that these are keyword arguments, but we know how to turn a dictionary into keyword arguments, which is by doing the double asterisk. We run that and we get exactly the same thing. Okay, so with single asterisk args, we can accept any number of positional arguments. With double asterisk quargs, we can accept any number of named arguments. Those are the only two types of arguments there are in Python. So this is how our decorator is going to work in the very next video. We're going to make our decorator accept any number of arguments of either type, and that's going to make our decorator generic for any function. I'll see you in the very next video.